All right. Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. I'm super happy to have all of you here today for our July Tech Talk. My name is Dalia, and I work as a community manager here at Kong. I'm super happy to have Inon with us today. And today we're going to talk about API security. He will have an amazing presentation for you. You get to ask questions at the end. Please use the Q&A function on the bottom so we can keep track of all of the questions there. He will answer them after he's done presenting. And of course, we are recording this webinar, so we will have access to the recording in about 2 hours after we wrap up the presentation. And we will also send you a follow-up email with some resources and the recording. So Inon, please take it away from here.
Thank you so much. Hey, everybody. Thank you so much for joining me. Excited to be here. And I wanted to say thank you for Kong and Traceable for organizing this webinar. Today, we're going to talk about API security, but more from the developer perspective. We're going to talk about the code flaws that lead to API breaches and how you can protect against those type of breaches when you create an API. And also, we're going to try to understand the perspective of the attacker when they attack APIs and how this process looks like behind the scenes. So before we even jump into the presentation, I want to just share a few words about myself. My name is Inon Shkedy. I did the security research at Traceable AI, and I have 12 years of experience in application security, and I've performed probably more than 500 pen tests so far. And also, I've grown up with APIs. So what does it mean? Basically, I started my career back in Israel. I used to be part of a team that provides consultation for government, military, and financial organizations in Israel. And as you can imagine, those applications, back in the day, it was more based on traditional technologies like ASP.NET, Java, SAP, and other concepts like multi-page applications, on-prem environments, waterfall. And if I used to see APIs, usually it was just for as a niche component of the application, for example, for B2B communication. After doing this type of job in Israel for 5 years, I decided to buy one-way ticket, and I moved to the Silicon Valley Bay Area in California. And for the last almost 7 years, it's been a long time, I've been working with this type of companies, and I got exposed to like startup tier 1 companies, and I got exposed to a new field of technologies like Ruby on Rails, Node.js, Elixir, and modern concepts when it comes to application development, such as single-page applications, cloud environments, CI/CD. And the most important part is that all of these new concepts are heavily based on APIs. So APIs are no longer just a niche component for B2B communications. Today, APIs are the backbone of the application. The next thing that I realized when I moved to the Bay Area is that if I want to stay relevant in the field of application security, I had to adapt my mindset and to understand how I can break into modern API-based applications. Because the reality is that when you perform pen tests, when you try to break into an app, it makes a big difference if we talk about a more traditional app or a modern API-based application. And this is how I got into the field of API security. I also lead a project that's called OWASP Top 10 for APIs. For those of you who are not familiar with OWASP, the organization, OWASP stands for Open Web Application Security Project. It's a non-profit organization and community that the goal of this community is to educate developers and pen testers about application security. So they provide guidelines and open source tools that helps you to protect your web applications and just to educate people about application security. Some of the most well-known OWASP projects are Mod Security, or CRS, which is basically an open source web application firewall. Many companies use it, and I'll tell you a secret, many of the web application firewalls, the commercial ones, they use Mod Security behind the scenes. So probably if you use any type of web application firewall, they're using some components of Mod Security behind the scenes. You also have Juice Shop, which is an app that allows you to practice your abilities in hacking web applications. It's kind of like a Hack Me application for pen testers and developers to learn about application security. They have Zap, which is a free application security testing tool. So you can download it and try to scan your web application for vulnerabilities. And then you have the OWASP Top 10, which is a list that OWASP publishes every 3 or 4 years that kind of summarizes the top 10 threats for applications. So, because the trends in application security are changing all the time, they publish a new list every few years to kind of like help developers and pen testers to navigate this field of application security and to say those are the top priorities you should care about. I'm the leader of the OWASP API Security Top 10, which is a list that we created for the first time in 2019, from the understanding that there is a big difference between traditional application security and API security. So I joined a few other people that are part of OWASP community, and we created this new list that defines the top 10 threats for APIs. It's a similar concept for the OWASP Top 10, that influences web application firewalls, but it's more dedicated for APIs and summarizes the top 10 threats for APIs. It got recognized by many API security vendors, press, analysts. In the field of API security, many people are using this this list as a resource for API security. And also, I want to mention that this list was created not because the leadership team decided these are the top 10 threats. It was actually a process of creating this list together with the community. We interviewed many people from the industry and also published the draft and got feedback from the community. And after many rotations, we just created the final version of the list. I have a link here for you guys if you want to take a look at the list. It contains top records, the 10 records. Today, I'm not going to talk about each one of them, but I'm going to talk about the main trends in API security and how you can, as developers, to prevent them. So before we talk about API security and the specific issues that might come up, I want to talk about the differences between traditional application security and API security. And this is something that I spend a lot of time thinking about, because I was trying to understand why the APIs and the modern application that I saw when I just moved to the Bay Area are so different from the application security perspective than the more traditional application security that I used to see back in Israel. And I think my main conclusions is that the traditional vulnerabilities that I used to find in the more older applications, they don't really exist in APIs, or it's very difficult to find them. And the reason for that is that new trends in application development, they mitigate the risk by design for these traditional vulnerabilities. Let's see an example. One of the most common vulnerabilities back in the days used to be SQL injection. Here on this slide, you can see on the left, there is a code that is vulnerable to SQL injection. The developer takes a parameter from the query parameter and concatenates this parameter with no filtering into a SQL query. So if I send a malicious SQL query, I can just execute it on the database, which is a very dangerous vulnerability. And I can just leak all the information from the database using this one mistake in the code. It's basically, as you can see, it's only two lines of code that leads to huge vulnerability. But SQL injection is a good example for a vulnerability that it's very difficult to find today in modern applications. And you know what's the reason? Unfortunately, it's not because developers became more aware of application security. It's just because developers today prefer to use other frameworks like ORM that prevent SQL injection by design. In most cases, it's still possible to write code vulnerable to SQL injection using ORM, but it's much less common. And the reason why developers use it is just because it's much more convenient. I personally know developers today that don't really know how to write native SQL, and they just use this abstraction on top of the database. So this is why SQL injection is something that is less common today. If we talk about file storage, so developers and companies moved from storing files locally on the server to storing file in solutions like Amazon S3, like basically cloud-based storage, which makes it much more difficult for the attacker to exploit vulnerabilities that are related to path manipulations. So back in the day, it was very common to find a feature in the website that allows you to download the file. And then you would just go back in the file directory using .. It's called directory traversal, and download files that you shouldn't have access to. And sensitive files, you might be able to download like configuration files with passwords and so on. And an example for this vulnerability you can find here on the left side. You just concatenate the file name and then read the file from the file system using a function to read from the file system. This is something that doesn't really happen today, or it's not very common to see it in modern applications because developers prefer to use Amazon S3 or similar solutions that prevents the attacker from accessing the local file system on the server, even if there is a traversal. Other examples is that, for example, because developers use today JSONs instead of XMLs, it prevents XXC, which is a vulnerability in the parsing process of XML, and a few other fields. Basically, the whole field of vulnerabilities that are much less common today because of new features and new frameworks in application development. So even though those scary vulnerabilities like cross-site script, like SQL injection and directory traversal are much less common today, attackers are still finding ways to hack your APIs. And this is something that we can see every day. Big companies get breached because of weak spots in APIs. Today, if we analyze, for example, the API vulnerabilities and breaches from the last year, we can see they are more focused on authorization, authentication, the abuse of sensitive business flows. Attackers will basically become more creative and more specific to the APIs. You need to understand better how the API works, the business model, in order to hack the APIs. And this is why we created this list, to understand the new trends in APIs. So let's jump into talking about API security issues. I want to start with authorization. This is by far the biggest challenge of API security, and most of the breaches that we can see today in the news when it comes to APIs are related to authorization problems. And authorization, to be honest, it's a very big field. It's not just one category of vulnerabilities, because it's kind of like an abstract concept. And this is why we have a few different items on the list that are related to authorization. So before we talk about the issues in the implementation of authorization, let's talk about what is authorization in APIs. It's, in a very simple words, just to dumb it down, it's a mechanism to determine who is allowed to do what in the API. Who can be a user, a guest, or an admin, and what can be a type of action, for example, accessing a function, deleting an object, reading information of an object, and so on. So the implementation of this mechanism is very challenging in modern applications. And I personally find authorization problems in almost every API that I test. And when we created the list, we tried to understand why is it so challenging to implement a decent authorization system. And I think the main reasons that I'm going to share with you are, first of all, if you compare authorization, if we think about authorization as some type of protection mechanism, we can compare it to other protection mechanisms like authentication. So the difference between authentication, which is basically the login mechanism, and authorization is that authentication is done in one place in the application. You might have one team or a few developers dedicated to create authentication system and to maintain it. So it's kind of something that is done by one part of the company, and you can also let your most experienced engineer doing it, or the most senior engineers. Authorization, on the other hand, it's a very decentralized mechanism. Authorization is a shared responsibility of every engineer in the company. Authorization can be done in the code, in the configuration file, and also it's something that might be done by the DevOps team, not even just the developers, also the DevOps engineers in the company. So basically, authorization it's a responsibility of every single developer and engineer in the company, which makes it very difficult to maintain it and to make sure it's done right. So this is one of the reasons. And then the second reason is that today in modern applications, you have very complex users, roles, and hierarchies, and we're going to talk about it in a bit. But it's just the concept that modern applications allow you to create different types of users. And you might have situations that one user has access to information of a different user. Planning the authorization from the more theoretical perspective to even to understand before you even go to code and like writing the policies, just to understand in your mind who should have access to what, even there it's becoming tricky. So I want to talk to you about 3 different types of authorization problems in APIs, and to understand how those authorization breaches look like behind the scenes. So I'm going to give an example for a vulnerable API, the Airbnb API. I haven't found anything on Airbnb, so no worries. It's just, I think it's a good example for a modern app with complex APIs and different types of users. So what happens on Airbnb? If you want to make a reservation and to book a property, there is a process where the guest has to send a reservation request, and then the host has to accept it. And the host might receive different reservations for the same day, and they need to accept only one. So what happens in a broken function level authorization is that during this process that the host is accepting the reservation, there is an API call behind the scenes between the client of the host, which it might be the mobile or the web browser, to the API, to the endpoint host/API/host/accept reservation. So basically, this API endpoint should be accessed only by a host user, right? What happens if a guest accesses the same API endpoint and accepts their own reservation? This is a scenario of broken functional authorization. It basically means that the developer doesn't validate that the user who is trying to access the function belongs to the right group. And this way, the guest can accept their own reservation, which is a problem. Other cases of buffer might be that one user can access admin functions in the API, for example. So you should always make sure that the user should have access to this function from the role or group perspective. So this is the first layer of authorization that you need to implement when it comes to the endpoint or the function level. Before we jump into the next authorization vulnerability, do you guys know what these companies have in common? Uber, Facebook, TikTok, Google, and honestly, probably all the tier 1 companies, they all got breached by a ball vulnerability in the last year. So the most common API vulnerability, which is the number one on the list, it's the top of the list, it's called broken object level authorization. You might know it as IDOR, it's the same type of vulnerability. And this is by far the most common vulnerability in APIs. Every time I test an API, I find a critical vulnerability that allows me, as the attacker, to read information of other users or even delete other users and many other scary stuff. So let's try to understand what happens in a BOLA or IDOR vulnerability. And we go back to the Airbnb example. So we said we have a layer of the function level authorization, and even if the developers made sure that the user belongs to the right group and the user is the host, what happens if we have a malicious host? And as part of the accepting reservation flow, the client has to mention which reservation you want to accept, because as we said, the host might have different reservations and they need to choose a specific one. So your client has to communicate to the API which reservation they want to accept or decline. And this is where the ID of the reservation comes into the picture. And this flow that you see an ID, which is a number, or a GUID, sent from the client to the API, it's a very common pattern in APIs. And every time you see an ID sent from the client to the API, it's a potential place to exploit BOLA. So what happens in a BOLA vulnerability? Very simple. I just change the ID from 919 to 918, for example, and then I might be able to accept a reservation or decline a reservation on behalf of a different host. And if I write a very simple script, I might be able to decline all the reservation on behalf of all the hosts on the Airbnb platform, and it would create a big problem for the company. So this is vulnerability. It's very easy to exploit it. I just need to change the ID to a different ID. It's even more easy if it's just a number and not a GUID. And even if it's a GUID, there are still ways to get the GUID of a different user. And then the last layer of authorization, it's called broken object property level authorization. So let's say that as a host, when I accept a reservation, I can also edit some of the properties. For example, I can leave a note to the guest, no dogs allowed, or something like that. Or please check in after 2 p.m. So as part of this process, there is an API call to the same endpoint, and I can send in the body of the endpoint, I can send the parameter that I want to edit. So what happens is sometimes the developers don't validate that you access a property of the object that you should have access to. So in this scenario, the user, the guest who wanted to reserve the reservation, they had agreed to pay, let's say, $100, but then the host would change the total price of the reservation to 1 million, and the guest would pay much more than they accepted to pay. And this happens because when you have an object, some of the properties should be private and some of them should be public. So some of the properties should be accessed directly by the user and some of them are not. Total price is a good example for a property that shouldn't be accessed directly by the user. And this is also a type of validation that you need to make sure that you have in your APIs. So I want to talk to you about some of the challenges and the ideas of how you need to design your authorization mechanism. And before we talk about the designing and the implementation of authorization, I want to talk to you about the concept of simple versus complex ownership when it comes to objects in an API. So a simple ownership of an object would be, let's say that I'm a user on a social network and I upload a profile picture. So I upload a new object, which is a profile picture, and it has an ID, for example, 414. So this is a pretty straightforward correlation. One user has access to one object, right? But what happens in an application which is a bit more complicated, a bit more complex, like Uber? So when Uber, you might be a rider and you want to take a ride. So you have access to this ride, which makes sense, right? But what happens if you take a carpool ride? Uber allows you to invite other people to a ride to save money. So then other users in Uber would have access to the same ride. And now Uber recently published a new feature that allows parents to monitor their kids' account. So in this case, both the co-rider, the main rider, and the parents of the main rider would have access to the same ride, and also the driver, right? So as you can see here, modern applications create a scenario where different users have access to the same object, and it becomes kind of chaotic to manage this access control system. And this is why usually when I look at the code of the authorization systems in these type of companies, it's kind of separated into two different components. When it comes to authorization, you have two components. The first one is the brain, the decision-making engine. This is where the complex logic comes into the picture. So you might, second. So let's say that talking about the scenario of Uber, you might need a function that is more complex to make sure that one user has access to a specific ride. So as you can see here, this function is more it requires more complex logic. It's not just like one-to-one correlation to make sure that the profile picture belongs to the current user. It's something that requires more logic. It should be written by more experienced engineers, the more senior engineers in the company that know the system better. And it's also like versatile, it's really based on the business logic needs. So Uber might decide tomorrow to remove the feature of that the parents have access to the children ride, and then this function has to be adapted. So this is like the engine, the brain itself, and then you have the authorization checks that has to be done in the controllers. So this is a much more spread out like checks of authorization. This is basically where you call the brain from. So every developer that writes a code that receives an ID from the client needs to make sure that they perform inside the controller the right authorization checks, or they call the brain, the decision-making engine, in order to make sure that the user has access to the IDs they are trying to access. And usually when BOLA happens, when authorization problems happen, it happens in the controllers themselves. Many times, even though there is the perfect authorization system, like the perfect brain, this part, many times developers just forget to call it, or they are not aware that they need to call it. So as we can see, authorization might be enforced in the controller itself, in the code. It can also be enforced in the configuration file itself. It's something that we see becoming more and more common. And it might be even enforced by the API gateway. So this is a screenshot from AWS API gateway. And you can see that AWS allows you to implement authorization policies on the gateway itself. So as you can see, it's a very spread out mechanism. It can happen in many different places in the application, not even only in the code. So just to summarize what we talked about authorization, it's a very delicate and complex system that requires a lot of attention. Unfortunately, there is no generic implementation when it comes to complex applications. You might have frameworks that would allow you to write your policies, but the reality is that it really depends on the needs of your application. Even if we talk about two different applications in the same field, they might have different needs. Like if we compare Uber and Lyft, they might have completely different needs when it comes to authorization. And also, it's not like something that you write only one and forget about it. It's something that has to be maintained and adapted based on the business needs and the new features that you add to your application. From the developer perspective, how you can prevent authorization problems. First of all, the most important part is when you expose a new controller or a new API endpoint, you should always ask yourself, what type of users should have access to this endpoint or function, to make sure that only people from the right group or the right role are accessing this endpoint. And then on top of that, you also need to make sure that when you process an object ID that was sent by the client, to make sure that the user actually has access to this object. And don't try to reinvent the wheel. If you should always check if there is already authorization function that I can use to validate this type of access. Let's say that a user is trying to access a picture. Maybe there is another library or microservice that your company uses for authorization that you can use to validate this type of access. Let's talk about the second item on the list, authentication. And authentication, it's basically the easiest target for attackers. And we can hear about authentication breaches all the time. Before we talk about the nuance of authentication breaches and how it happens, I want to talk about the evolution, because you might know authentication problems from like different terms. So the most primitive, the more simple type of authentication breaches happens because of raw brute force. Let's say that I know there is an admin user and I want to guess their password. I would just try all the combinations from like 0000 to ZZZZ, and I would hope that after some attempts I would find the right password just by brute forcing all the possible combination, which is kind of a long process, right? And then attackers have evolved to use dictionary attacks. It's based on the idea, on the assumption that when users choose a password, it usually contains like real words from like real languages. So they would just take like the most common words from different dictionaries and combine them together. And they would add maybe like a few numbers before or after, and then like they would like try combination like cat 1 2 3, password 5 6 7, and so on. This is a bit more advanced. And then what is more common today is called credential stuffing. So credential stuffing is kind of a scary concept. What happens is the attackers, they compose lists of leaked username and passwords. So let's say there was a leak on a website, and the attackers of another website managed to leak all the passwords of all the users of let's say MySpace. There was like a big leak of MySpace. So if you want to perform credential stuffing as an attacker, you would take the combinations of username and password from MySpace, and you would try each one of them, but not on MySpace, just on a different system. For example, you say, okay, I assume that because users usually use the same passwords in different websites, I would just take the combination of the email and the password and try it on Facebook and Instagram, for example. And this is what credential stuffing is basically. Attackers just create huge lists of combinations of username and passwords that have been leaked in the past and try to repeat them in other APIs. Just a few examples from the last year. 23andMe, 7 million accounts, almost 7 million accounts got breached because of credential stuffing. Roku, the TV provider, more than 500,000 accounts got compromised because of credential stuffing, and it's just like a few examples from the last year. This is something that happens all the time. So why do you guys think that attackers target authentication? The reason it's pretty simple. It's a mechanism that's exposed to everybody by design. It's not like authorization that you need to understand the application, you need to create different users, you need to understand the like complex relation between users. It's just like a login page that has a username and password, and you can access it pretty quickly because this is the first barrier when you access the app, the authentication mechanism. It also makes it very easy to automate the exploitation of authentication breaches because most authentication systems look similar. It's just a combination of username and password. It's much easier to automate. And it's also pretty easy money. It's like you can sell leaked users on the darknet for, it depends on the type of website, but you can sell it for pretty good money. And it's not very easy to automate. It's not very hard to automate this process. And it invites a lot of people that don't have very deep experience in application security. They don't really understand the depth of application security, but they can just make easy money by using automated scripts and to learn a little bit about credential stuffing, and they make pretty good money out of it. So after we understood the perspective from the attacker, let's talk about the protection that you need to implement when you create a secured authentication system. First of all, you need to put rate limiting in place. Rate limiting in place, it's a pretty simple mechanism that says something along the lines of, if a user is trying to access my login endpoint more than 5 times in 1 minute, I should block this IP address, or I should block the user that they're trying to breach. Other protections that can help to prevent this type of attacks is CAPTCHA, to make sure that the person who is trying to log in is a real human being. And also you might have some configuration errors when it comes to authentication. For example, if you store plain text passwords on your database, this is a very dangerous error to make. And it's a combination of different things that can happen in the configuration level. And if you guys want a good resource to learn about authentication problems and how you can prevent them, I have a reference here for another OWASP project, which is basically the authentication cheat sheet, and you can find about the different type of configurations and rate limiting rules that you should apply in your authentication. And I also want to mention, it really depends on the industry and the business needs of the company, because the more you make it harder to authenticate, and basically the more protection you put on the authentication, usually the user experience becoming more annoying. So some companies, depends on the risk and the risk management, decide to implement different solutions in different levels of security. So as you can see, probably notice that like in some websites, if you try to log in only a few times, you wouldn't be asked for a CAPTCHA. But if you try to log in more than 5 times, you would be asked for a CAPTCHA. And then if we talk about companies that are a bit more sensitive, like banks or Robinhood, for example, they might ask you for a CAPTCHA for the first time. So it's kind of a subtle mechanism, and it's also like something that you need to adapt based on your business needs. But the good point about authentication, if you compare it to authorization, it's something that you you kind of implement in a few places in your application. It's not something that every developer in the company has to know about it. Let's talk about common misconceptions when it comes to authentication. And many times when I see authentication breaches, or if I find authentication weak spots, they happen because of this misconception. First of all, it's really important to understand what does it mean, an authentication endpoint. The most simple example would be a login endpoint, right? You just like there is an endpoint, it receives a username and password, and you say, okay, this leads to authentication, I need to protect it. I need to put rate limiting in place and a captcha. But what many times companies forget is that there are other endpoints that would lead to the same flow. Because we don't really care if the user is using a username and password or a different mechanism to authenticate, as long as they get an authentication token back and they can use it to log in on behalf of the other person, you should consider it as authentication endpoint. So other examples for authentication endpoint would be forget password. Even though there is no password involved because you just get a token to your email or your phone, it still leads you to authentication. Or if you have an impersonation feature, it allows one user to, like one admin, to log in on behalf of a different user. It's also some type of authentication because the user would get access on behalf of the other user. So all of these endpoints should be considered as authentication and should have the right protection. Then another example for authentication misconception is that older versions require less attention. This is something that unfortunately I see in many companies. They would put a good authentication protection mechanism like rate limiting and captcha on the new versions of the login, but then they would forget to protect the legacy or the older versions of the login endpoints. Many times they just leave them open to the internet to support older clients, but they forget to put the right protections. And another mistake that you might see is that you would put a protection on the production environment, but then you would forget about the QA environment or the beta environments. Some of them might be even connected to the same database, so it's the same username and passwords. So it's very important to make sure that all these environments have protection for their authentication endpoints. And then some misconceptions around rate limiting. Something that I recently found in one of the API that I tested is that the rate limiting was based on a session ID in the cookie. So what happens basically after I try to log in, like after a few failed attempts, I would get a cookie, and if I send the same cookie, I would get blocked. But if I just delete the cookie, I can bypass this mechanism. So we covered authentication, and I want to jump into the next API security issue, which is unrestricted resource consumption. It's number 4 on the list. And basically what happens in unrestricted resource consumption is that most APIs don't limit interactions or resource consumption, and it can lead to things like denial of service or increased operational costs. Basically, I make the company lose money. Let's see an example for that. And this is kind of an example that I personally found it in most of the API that I tested, even like the big e-commerce websites in the US, they're vulnerable to this type of attack. So let's try to understand how we can make a company lose $1,000 in a matter of 1 minute, okay? And it's very simple. You can also try it. Just don't tell anybody I told you to try it. Let's say that you have a social network API, and then there is an endpoint to send verification token to your phone. And as part of this flow, you need to send your number, right? And then the social network, they would send you a verification token so you can use it to log in or do something else on the API. But the developers of the social network, they don't know how to send SMS message, right? They just use a third-party API of Twilio to send the SMS. But Twilio also need to make money. So they charge the social network some money, like let's say they charge the social network 10 cents, which is not a lot, for each SMS that they send for the users of the social network. So this is okay, right? It's not a big deal. But what happens if I take this, an attacker takes the same API call of send verification token and repeat it for like 10,000 times? And this is something that you can automate using the script and do it in less than 1 minute. you would basically increase the cost that the social network pays to Twilio, and you would make them like lose $1,000 in 1 minute. And you can just keep going with this attack for however you want. And what we are saying that many companies don't protect against this type of vulnerability. Some of them might not even consider it as application security issue, but the reality is that it's kind of scary how much money they can lose from a very simple attack. The other type of unrestricted resource consumption is that if you have a function on the API that consumes a lot of memory or CPU, it's something that you also need to be mindful about. So let's say that you have an endpoint to upload an image, and behind the scenes, the social network creates smaller versions of the same image, the thumbnails of the same image. This is an expensive process. Graphical processing usually requires a lot of CPU and memory from the server. And then an attacker can just upload a really large file, like a really large PNG image, and the social network would try to convert this image to smaller versions. And it might actually crash the server or the microservice, and then the microservice wouldn't be able to serve other users. How we can prevent unrestricted resource consumption? It's very important to implement rate limiting, and and to block users who try to access those expensive endpoints again. Let's talk about the server-side request forgery, which is kind of like a fun API vulnerability. It's pretty straightforward. What happens today is that you have features in APIs that supports the user to send a URL, and then the API would access this URL externally. So one simple example is that you have an option on Facebook. You can upload an image from your device, or like from your computer or mobile device, but you also have an option to add the picture from a URL. So you can just send a URL to the API of Facebook, and then the Facebook API would try to download this image from the URL that you provide. What happens if you send a file, instead of like just sending like an innocent image, you just send a really large file of 10,000 gigabytes. You would cause the API of Facebook to access this file and try to download it, and it would consume a lot of the resources of the Facebook API. It might even lead to denial of service. This is just one example of how you can exploit SSRF. A different example would be if you have an option to send a message in some type of platform that allows users to communicate with each other, and you have an option to add external file from a URL. So instead of like sending a file of like an external article, for example, you might be able to refer to a local file that exists on the local microservice. So instead of accessing an external service, you would make the API access themselves and to add the content of the page to the attachment of the message that you send. And this is how you might be able to access a sensitive file on the server. So this is kind of the new generation of directory traversal. Then let's jump into improper inventory management. This is not the most exciting, it's not the sexiest vulnerability, but it's something very important to think about and to be mindful about when you write APIs. It's more like housekeeping. It's really important to know what you expose. In reality, many times when I talk to companies and I ask them, I see like a bunch of microservices, a bunch of APIs. I ask them, what is the purpose of this QA-3-something environment? And they tell me, we don't really know. Someone exposed it like a long time ago. The person left the company and we don't really know what it is, but we're afraid to remove it. So this is bad because you can't really protect what you don't see. And you need to have a process in place to document and also to deprecate all the APIs, microservices, and API endpoints that you don't need. Different types of improper inventory management would be, one example would be if you have a banking payment API that has 3 different endpoints. You have the V2, download transactions PDF, and this is documented. You can find documentation. It's okay, the developers know what is the purpose of this endpoint, but then you have an endpoint like V0, legacy, B2B, export all users. this endpoint has no documentation. If you ask the developers, they don't know how to answer what is the purpose of this endpoint. They might not even know who is the right team that's responsible for this endpoint. And this is one example for improper inventory management, that you just have endpoints with no documentation that you just don't know about. And some companies might refer this problem as zombie APIs or orphan APIs. Another example that also it's pretty common to see is that you have microservices or even like whole environments that are exposed to the internet directly. So the thing about API gateway, if we go to the first slide here, you can see that the API gateway enforces many security features. It can enforce authentication, encryption, and other stuff that's very important. But then sometimes what we see is that developers or DevOps engineers, they expose a microservice directly to the internet, allowing the attacker to bypass the API gateway and bypass different protection mechanisms that the API gateway enforces. So this is also some type of improper inventory management. So let's summarize the improper inventory management and how you can prevent it. You need to make sure that you document all the API endpoints that you expose, and to have a process to review and deprecate all the API endpoints and environments. I think it's important to explain it to the developers in the company and also to the DevOps engineers, and to have a culture that everything is documented, even if you expose a temporary feature. If you have something that would be exposed only for a few days, you still need to have a process to know like when to deprecate it and documentation for this feature. So we are getting closer to the top of the hour. Let's summarize what we talked about today. First of all, API security is a challenging field. The reality is that many of the traditional security vulnerabilities that used to exist back in the day, like SQL injections, don't really happen today, which is good news. But still, attackers find very creative ways to attack your API, and we keep hearing about this in the news all the time. So it's something that we need to be aware of, and to make sure that we have the right protections in place, use the right solutions to protect your APIs. By the way, my company, Traceable, has a pretty cool solution to protect your APIs. You're welcome to book a demo. And also, we need to remember that authorization is the biggest challenge, and companies must invest into it to be protected. It's not something that you can just like ignore. And the reality is very difficult to protect against authorization issues. And companies like Traceable, like our company, helps you to have a better solution and to find it also the blind spots when it comes to authorization issues that you might have. And API security is a field that keeps growing and keeps changing, and we see new trends in the market all the time. So we are, as the OWASP API security project, we keep updating the list with new API threats, and we will keep the community updated with all the new changes. I hope you guys enjoyed the presentation. You can feel free to reach me on Twitter or LinkedIn. Always happy to chat about API security. Thank you so much. And I think now we have time for questions.
Thank you so much, Inon. That was awesome. And I think we have 3 questions in the Q&A.
Let's see. The first one, can ball authorization be executed on a database in query? We check if host has access to the given authorization and if this ID is the same in the request. Yeah, it can be implemented in the database query if it's a more simple type of authorization. Let's say, for example, you have, if we go back to the profile picture example, maybe the profile picture object in the database, in the same table, you have the owner of the profile picture. So you just can make it like a pretty simple query. But if we talk about more complex type of authorization, like for example, if different users have access to the same object, it's something that might need to be implemented in the code itself. And I think it's also easier to maintain and implement those checks in the code and not in the database query. let's consider a microservice environment. What is the best layer to execute authorization? Gateway. It's a good idea to make authorization also in service layer. Yeah. So when you talk about authorization, it really depends on the company structure. I would recommend to implement the function level authorization in the API gateway. I think it's good to have it in one place if it's something that you can do based on your code design. Sometimes there are more complex authorization decisions, even in the function level, that you need to answer in the code itself. But in general, it's something that's possible to implement in the API gateway or the configuration itself. I think there was another part of the question. So in terms of authorization, so there are two types of authorization, right? There is like authorization when you expose an endpoint to the internet, which is the most critical type of authorization, because these are the endpoints that are exposed by design to everybody. And then there is also authorization between microservices. So the first priority should be to protect the APIs that you expose to the internet. And then obviously it's very important also to create authorization and authentication in between the microservices themselves in the service layer. Especially today with vulnerabilities like SSRF that we talked about, it makes it easier for attackers to kind of like perform lateral movement and to make the API make internal requests into the microservices. And this is where authentication and authorization between microservices can really help. What is the best approach to show some images from another pages on my website? I have URL to the image. There are some libraries you can use to make sure that the URL is safe. Basically, you need to make sure that the URL is of an external website and not your own machine or something in your local environment. So to make sure it's not like a private IP address. And then also to perform checks that to put some timeout. If you try to download a picture, for example, don't if you see that after a few seconds the download is not completed and it's a very large file, you should just cut the connection and don't keep trying to access the picture. Next question. How do you personally approach these topics when you're starting a project? I think it's something that is very important to make sure that you educate the developers and also the engineers in the companies when it comes about API security, even before you start the project itself, not just even before you jump in the code, just like to have like education in the company about API security and all these issues that we talked about. And also just as part of the designing of the API or microservice, to make sure this is something that you put resources into, to think about authorization, authentication, and all the other items that we have on the list. And next question, how about API management, like in Azure APIM? Some of the API management solutions might tell you that they do security, but you should take it with a grain of salt. Many of them, they might have features like encryption and simple authentication, but usually it's not enough to protect you against all the API security issues. API management is for management, and API security solutions would help you better to prevent the more sophisticated, the more dangerous type of API security issues. So for encryption, I think API management would be great. But for other like more delicate, more complex business logic vulnerabilities, they're not enough to protect you against. Do you have a checklist that you follow when you're testing API endpoints? So you can take a look at the OWASP API project. We do have a checklist there that you can follow, and basically to go to each one of these records and try to understand the posture of your API. Next question. is there something similar to MFA that can be used in an automated API authentication context, which often just rely on user password for authentication? MFA can be also used in APIs. It just requires a different type of integration. I'm not very familiar with the field, so I don't want to give you the wrong answer. I can do some research and get back to you, Daniel. Another question, is there a way to discover all available API in an organization? Yeah, it's a good question. Like, first of all, you need to make sure that you have documentation, just, part of the education to make sure that developers document all the APIs. Documentation would be the most simple point of discovery. And then you have tools like Traceable that would, basically what we do in Traceable, we would monitor the API traffic to your API. And based on that, we would reverse engineer the API DNA, which is basically the API documentation on steroids. So on top of understanding what are the parameters that are being sent to the API, we also understand what type of values, what are the relationships between the users and the API and the API endpoints. So the first point where you can discover all the APIs, it's just API documentation. But then if you want a more complex, deeper understanding of the APIs, you can use a solution like Traceable. And I can tell you that every time that we are in a POC with a company, we help them to find those zombie APIs that they're not aware of. And these companies usually get really surprised. Oh, we didn't know that we have this legacy authentication endpoint with no protection or no encryption. I see that we have one last question. What kind of bike do you have? I do have a nice specialized bike. It's a good question. I bought it during COVID. I was bored. I was looking for a new hobby, and I decided to buy a bike when I was living in San Francisco. Pretty fun bike.
The award for best question this evening. All right. Any last questions for Inon? Let's see if we have anything. All right, we're right on the hour. Thank you so much, everyone, for asking amazing questions. And Inon, thank you so much for coming to the Tech Talk, for great presentation, for answering all those questions. We'll gladly have you again join us sometime. And thanks, everyone. I hope you have a good evening, good day, and we'll see you in our next webinar.
Thank you so much. Appreciate it. Thank you, everybody.